All right, so boys and girls, we're back to the magnet and on the stool project again. And I want to just talk about a couple of more things before we leave this behind. So right now, there's a magnetic force pulling the paperclip to the magnet. When I pull away and the magnet is floating in the air, right now, whoopsie, right now, the forces of magnetism and the force of gravity are balanced. They are equally pulling on the paperclip, and the paperclip is not moving, right? It's still. It's attracted to the magnet, and gravity is pulling on it, but because the paperclip is not falling, the forces are balanced, okay? But when I pull the paperclip far enough away and it falls, then we have an unbalanced force. The magnetism becomes weaker than the pull of gravity. And because gravity is the stronger force at that time, the paperclip falls. Now, if I put more magnets on the stool, my paperclip will be able to stay out a farther distance. Why can I say that? Well, we just did an experiment that showed that the more magnets you increase, the stronger the magnetic field. So I'm able to pull the paperclip out farther without gravity acting on it and making it fall. That's quite a distance. But now we had unbalanced forces again, and gravity pulled down the paperclip. Okay, so boys and girls, I have a chair here, and right now my chair is stationary. It's not moving. There are no forces acting on this chair. Now that's not exactly true because gravity is pulling down, but right now I'm not making the chair move, right? However, if I push on the chair, I am pushing in this direction. What direction is the chair moving? In the same direction. So right now, I'm pushing this direction and the chair is moving in the same direction. Let's do it again. Here the chair's not moving. I'm going to push on the chair and the chair moves in the same direction. When the chair moves in that direction, when there's motion, there is an unbalanced force. Okay, so boys and girls, you guys all know Miss Ava. And she's going to help me do an experiment showing balanced and unbalanced forces. So right now, the chair has balanced forces because it's not moving, okay? Now, I am going to push on the chair this direction, and Miss Ava is going to push on the chair this direction, and we're going to see which force is stronger. Okay, I have the stronger force because I was pushing harder. When my force in that direction is stronger than her push in the other direction, the chair moves. But guess what? We're going to do it again. Oh, that time Miss Ava was the champion. So this time she had a stronger force than mine. Thank you, Miss Ava.
You're welcome.
So if I have a large force, a large pushing force in this direction, and a small pushing force in this direction, my chair is going to move in that same direction as the larger force. However, if the forces are switched and the larger force is on that side and the smaller force is on this side, then the chair moves in the direction of the larger force. This is an unbalanced force. Now, what happens with a stool? What happens if I'm sitting on the stool? I'm not moving. Aren't there some forces at work? What's pulling me down? Gravity, right? Gravity is pulling me down. And gravity is pulling me down like that. Okay? So if gravity is pulling me down, I should just be lying on the floor. What is pushing up? I know it's hard to believe that the chair is pushing up, but that's what's happening. And the chair is pushing up with the same amount of force, or else I would fall and be on the ground. So the chair is pushing back up with the same amount of force, and that's why I don't move. To make it a little clearer and easier to understand that the chair is pushing back up, is I'm going to hold this book. So I can feel gravity pulling down on the book. And I have to push back up against gravity in order for the book not to fall. So right now, I have balanced forces. Gravity's pulling down and I'm pushing back up. But if I don't push back up, gravity takes over and we had unbalanced forces. Boys and girls, please take out your science notebook, and I want you to glue this page into your science notebook. This is going to be the next page, and for me, it is September 10th, and I put the date at the top. You are going to put the date that you do this lesson. So you're going to cut this, you're going to trim this page, and you're going to glue it into your science notebook. Do that now. Okay, now I want us to look at this question. Response sheet, investigation 1. Write your answers on a blank page of your notebook, not on this sheet. Number 1, student A pushes on a cart with 500 units of force. Student B pushes on the other side of the cart. The cart does not move. How much force is student B applying? Explain why you wrote that answer. So, before, I didn't put units when I did our experiment, did I? So, I have A on one side, I have B on the other side. Is the box moving or is the cart moving? No. So we know that the forces are going to be equal. So I'm going to try to draw an arrow about the same length as the other one. If this side is pushing with 500 units of force and the box is not moving, this side is also pushing with 500 units of force. Number 2, explain why the apple is not moving. Describe all the forces at work when you are holding an apple in your hand as you see in the picture. Okay, so boys and girls, that's kind of like when I was holding the book, right? When I was holding the book, what happened? Gravity was pulling down, right? And let's say gravity was pulling down with 500 units of force. But if I'm holding the book up and it's not falling, I'm holding it with how many units of force? The same amount, right? As long as the book is not moving, the forces are balanced. So boys and girls, this is what I wrote for number 1, 500 units of force. The cart is not moving, so the forces are balanced. And for number 2, I wrote, the forces are balanced. Gravity is pulling down on the apple, but the hand is pushing up with an equal amount of force. Girls, please make sure that you do this reading in your science textbook. You're going to go to Change of Motion, which is on page 12, And you're going to read that all the way until page 17. All right? I look forward to seeing you next time, guys. Bye.